Any of you aren't sure on? All right. If not, we'll look at 1.2. 1.2, we're talking about transformations. We're talking about transformations of functions, and specifically kind of how they relate back to the parent function. Now, graphing, unless I specifically tell you to graph on a homework assignment, we're not graphing. I'm not having you graph. Graphing is nice, it's important, but we have a lot of tools and resources at this point that can graph for us. All through geometry, especially the Desmos, graph for you. You put the equation in, it graphed it for you. So actually being able to graph on a quadrant plane, I don't think is as crucial as it used to be, because we have so many resources at our disposal that will graph for us. Being able to read the graph or know what it's doing or what it's going to do, I think is a little more helpful. So being able to understand the transformations and how they apply and how it's going to behave, if we get that, being able to actually graph it exactly is less important. And it's all based off of these here. At least these are the ones we'll look at. Constant, linear, absolute value, quadratic. When we apply transformations to it, it's going from the parent function, the original form, to the new form, what we're doing to it. Constant doesn't tell us a whole lot. Constant is just a straight flat line, y equals 1. That's the parent function for any constant or horizontal line. We can move it up, we can move it down. That's about all we can do. It just equals a number. Linear, y equals x, f of x equals x. This is the parent function for any and all linear equations. I know you all have done a lot of linear equations, especially Algebra 1. Y equals mx plus b. This is the most basic version of a line. We can move it up, we can move it down, we can stretch it, we can shrink it. Any transformation we apply to it to get us to any other equation of a line. Absolute value. Y equals the absolute value of x. We know it's an absolute value because of two main reasons. Graphically, it's going to be a V-shape. Absolute values are always V-shaped. Also, as an equation, it has absolute value bars. Absolute value equations kind of give themselves away because as we read it, we have to say the absolute value, so it's an absolute value function. And the last main parent type that we're going to look at is quadratic, this x squared, this term being squared. Now, a lot of the quadratics, we call them in their own family higher degree polynomial functions, polynomial equations, is based off the variable with the biggest exponent. That's the name we give it. And we'll talk more about it, especially into chapter 4, where we talk about higher degree polynomial functions and actually naming them and knowing how to name them. But here, x squared is our quadratic. Questions over these three parents? They're not the only parent functions. We have cubics, quartics, radicals, rational. Each and every type of equation has its parent function, its most basic form. But the main three we're going to look at is linear, absolute value, and quadratic. Now, types of transformations, might as well look at the general form. This is the general form for each one. Now, there is one other letter we'll put in there when we hit 1-3. Not too concerned about it. It's B. I will show you here in a second where that's put. But a lot of what we do and a lot of the ways I approach describing transformations always come back to these here, come back to the general form. What is taking the place or what is in A, H, and K spot? Because the number or sign, depending on which one it is, tells us what the transformation is. H, and K all have a specific piece of information that they're telling us depending on what their values are. And as we start with this and start looking at them, we're going to look at them independently, and we will eventually see some that have multiple translations, have multiple values in these spots. Ready for the first type? Almost got it? Okay. If at any point you need me to slow down, tell me. If you need me to pause, I can pause. I don't mind scrolling back up. So our first type of transformation is a translation. A translation translates so a transformation changes the size, shape, position, or orientation of a graph. It changes everything. That's what a transformation is. That's all of what we're covering here. A translation is a transformation that shifts the graph horizontally or vertically, but does not change size, shape, or orientation. We're literally just moving it up, down, left, or right. That's all we're doing with this here. We're just moving the function up, down, left, or right from its starting position. Now with this, I like putting it right here. One of those is H. H is going to be our horizontal translation. Left or right. K, vertical. Is moving it up and down. If we have a value for H, it's telling us how far we're moving to the left or to the right. If we have a value for K, it's telling us how far we move up or down.
Wait. Are the things at the end, are those K's or are those R's?
K's.
Okay.
Yep.
So then where did we get the R from? So then why did... Oh, okay.
Yep.
Thank you.
You're good. Yeah, no, I switch between cursive and print constantly. So if something, it's hard to tell what it is, ask. I will definitely specify. That goes for the test too. If you're not sure what it is, ask. All my tests are handwritten. So our value of H is going to tell us how far we move to the left or to the right. Kind of the opposite of what we think. K is going to tell us how far we move it up or down. Now, one of the interesting things with this here, and especially general form, H and X are always going to be paired together. Y and K are always going to be paired together, especially when we talk about equations. If you think back to last year, circles, equation of a circle, X minus H squared plus Y minus K squared. X and H, Y and K, pretty much every single equation, they go together. They always stick together. It is nice because that does help us, especially when we're talking about graphs or in general, H and X, Y and K. Now, questions on this so far? Well, we really haven't covered much. We just said that H talks about left and right, Y and our K is up and down, H is left and right. So let's actually put some context to it. So we look at this first one here. Now the first equation, the first problem is kind of hidden a little bit. So we're looking right here. Say g of x equals x minus 4. Right there with example 2, example 1. We all see that? Yeah. Example 2. Graph g of x equals x minus 4 in its parent function, then describe the transformation. So we're not so much worried about the graphing it. But the two main things we want, the first one is determining what is its parent function. Which of the three, absolute value, quadratic, or linear, would x minus 4 be? Linear. Yeah. You're good. It happens every year. It gets hidden in there. I need to make it a little bit bigger. X minus 4 is a linear function. Now the general form, y equals a times x minus h plus k is this here. Now for the most part, especially with linear, we're not really going to have a value for h. And we don't have one here, because if we have a value of h, it's going to be inside those parentheses, being added or subtracted with x. Do we have parentheses here? No, unless they're specifically written, we don't have parentheses. I mean, we can add them or make them, but there's no parentheses, which means there's no value for h, which means the function is not moving to the left or to the right from the parent. Do we have a value or a number in place of k? And that number is 4. Now, it's not just 4, it is negative 4, yes? And again, we're describing the transformation. We're trying to say from the parent, how did it move? How did we move to get from y equals x to y equals x minus 4? How has it been transformed? Since it's minus 4, because again, we're talking about up, down. Up is normally positive, down is. So if we're saying k is negative 4, we're moving where? Down, how far? 4. That's the transformation. It's a linear function, and it moved down 4. So if we're looking at the parent function, this is it here, yes? So knowing about this transformation, I know that every point on that line should go down 4. And we'll go over actually how to use this. X minus 4. Lo and behold, the whole function moved down 4. This is graphing it, it does it for us. Desmos will graph it for us. But if I know what the parent is, it's y equals x, and I know that the transformation says it moves down 4, I now have an image in my head or something close to it of what the graph should look like. I think that's more important than actually being able to graph the thing. Questions on this here? Let's look at the next one. G of x equals the absolute value of x plus 1. What's our parent function? Absolute value, yeah, absolute. I always go back to the general form. Y equals a times absolute value of x minus h plus k. Do you have to write the general form every time? No, but I do find it helpful to describe these transformations by looking back at it. Because if we look at this here, what's the value of k? There is no value of k. It's 0, yes? We do not have to say that it was moved up 0 or down 0. Okay? It'd be the equivalent of, if I said we moved up 0, down 0. It'd be almost, I think, the equivalent of saying, on my way back to Siloam, I did not go by New York. Well, there's no reason to. There is no transformation. If nothing's being done to it, or the transformation is not causing a change from the parent function, there's no reason to list it. So it's the fact that it did not move up or down, we're not even going to list it. Like on the last one, we did not say that it moved left or right. There was no value there. We do not list it. However, is there a value in place of h? It is 1. Now the question is, do we move to the left or to the right? Right, because it's plus, yes? All right. Now it takes a little bit more buttons to hit to get there for this here. There's our absolute value, yes? X plus 1. And as we can see here, the graph definitely moved 1 unit to the right, yes? No, it moved 1 unit to the left. Okay. Got to mark that out. Wasn't to the right. It was to the... Look at the general form. What is our general form? X minus h. The general form is x minus h. So the only way that I can go from x minus h to x plus 1, the main way we can change a negative to a positive is with another negative, because a negative and negative make a positive. So really, if I'm looking at transformations, we're not actually looking at x plus 1. We're actually looking at x minus negative 1, because the negative and negative make a positive. So to actually change up or match the general form, h is negative 1. Inside the parentheses and absolute values, it's going to really be the opposite of what we think, especially with horizontal translation left and right. When we get to it, horizontal stretch and shrink, really opposite of what we think. So it looks like we should be moving to the right, but we're actually moving to the left. And when we have that x minus 1, we'd actually be moving to the right. Because if I come down here and switch it to x minus 1, it does indeed move it to the right. It is funny the way it works, and it's really because it's x minus h, it's throwing everything off. Up and down is fine because it's plus k plus that amount. We're not going to say plus negative 2. We're just going to say minus 2. Just like inside the absolute values, we're not going to say x minus negative 1. Negative and negative make a positive, so we're going to say x plus 1. It has that opposite effect to it. Questions on this here? All right. We are going to come back to it. We are going to do more of them. But we're going to look at reflections first. A reflection is a transformation that flips a graph over a line called a line of reflection. All the points are the same, but they're equidistant to whatever that line is. Now for this here, we're mainly going to reflect one across one line today. For the most part, we only have two that we're really looking at. One of them is the x-axis. The other is the y-axis. If A is negative, we have a reflection across the x-axis. You could put this, I'd put it underneath the first page. If A is negative, it's a reflection across the x-axis. If A is negative, it's a reflection across the x-axis. So when we look at the general forms, that A, we're looking to see, is it negative? Not so much is it positive. If it's positive, there is no reflection across the x-axis. Is A negative? If yes, it's a reflection across the x-axis. That's it. Now notice we're not saying anything about the numerical number of it. If it's 4, 7, 2/3, 9/2. Is it negative? If it is, there's a reflection across the x-axis. That's it. Well, what does that mean? Well, if we look at the one right below it, p of x equals negative x squared. What's its parent? Quadratic. We'll get to the A here in a second. Is there a value for K? No. So that tells me that there's no movement up or down. Do we have a value for H? No. If we had a value for H, we would need parentheses for us to be able to add or subtract it to the X value inside, yes? No parentheses, so no H. Is there a value for A? Yeah, it's 1. But since we do have something in place of A, we have something there, yes? Is it negative? So that means there is a reflection across the x-axis. It's almost like we're treating this like a checklist, isn't it? Is there something in place of H? If there is, that means we got a movement left or right. If no, we move on. Check K. If K has a value, that means we're moving it up or down. If no, nothing listed there. A is negative. Reflection across the x-axis. If A's value is positive, there is no reflection across the x-axis. We just move on. That's why I like these general forms. Because if you're starting to notice, we're just looking, is there a spot, a value in these spots? If yes, this transformation occurred. If not, that doesn't. We're starting to see how these work. Kind of, sort of. We're going to do more. This isn't, we're doing 2 and done. We're doing more. Any questions on negative x squared? Are you ready for the next one? K of x equals negative x. What's the parent? Linear. It's line. We can just go top to bottom. Is there a value for H? No, so there's no movement left or right. Is there a value for K? K have a value? No, so that means we're not moving it up or down. Do we have something in place of A? We have the negative, yes. If A is negative, there is a reflection across the x-axis. There should be an X. No, there's not. I don't know why I was thinking that there was an X. Across the x-axis. Reflection. A reflection. Questions on this here? Do you feel at least semi-comfortable with it so far? Okay. Now, before we start the next one, let's have some more translations like these here. X plus 3. G of x equals x plus 3. What is the parent? Linear. It's equation of a line. Do we have something in place of A? Is A negative? No, so do we have a reflection? No. Do we have something in place of H? Nope, we don't have parentheses. We need parentheses for H. How about K? And it is 3. K moves in what direction? Up and down, yes? Which direction would we go? Oh, up and down, exactly what it looks like. Positive, so we're going up. Negative, we go down. Vertical is nice. It's exactly what it looks like. Any other questions on 2 before we look at 3? X minus 2 squared. What would the parent be? Quadratic. Is A negative? Is A negative? No, so is there a reflection? No. Is there a value for H? What is the value? So we do have 2. And the negative positive is really going to tell us if we move to the left or to the right, yes? So it's X minus 2, which feels like it should go to the left, but it's actually going to the X minus 2, X minus H. X and the minus do match up, so it's telling us the value of H is actually positive 2, not negative. So this actually moves right too. Questions on this here? We ready for the last one of this set? N of X equals negative absolute value of X. Parent is absolute. What would our transformation be? Because A is negative, so we have a reflection across the x-axis. Might be wondering, can we just say reflection? Unfortunately, we just can't say reflection. We've got to specify the axis because there are reflections across the y-axis. So we need to be able to say or distinguish between the two. Questions on number 4?
I'm looking at reflection across the x-axis again.
So the value for A, is it negative? Or where the number would be for A? So we have that negative in front of the print absolute values. For this here. Since this is in the location of A, if that spot is negative, it's a reflection across the x-axis. Mm-hmm. Does that answer that? Yeah, that's it. Any other questions? Now, I did specify y, because where is that going to show up? I'm going to go back to the front. If the sign inside the parentheses or absolute values in front of that x is negative, then it's across the y-axis. I will, especially 1, 3, we will put a b in that location, but that's all it is. Question on any of these 3 here? Vertical stretch, vertical shrink. Another way to transform the graph of a function is to multiply all the y coordinates by the same factor other than 1. Multiplying by 1 doesn't change anything. If the value of a is greater than 1, it's a vertical stretch. If the value of a is between 0 and 1, it's a vertical shrink. So we'll add this to it. If a is greater than 1, it's a vertical stretch by that factor. If a 0, well, that's actually a little more room. 0 is less than a is less than 1, it's a vertical, if I can spell. So if the value of a is greater than 1, it's a vertical stretch. If the value of a is between 0 and 1, it's a vertical shrink. Now, technically, we would say the absolute value of a. If the absolute value of a is greater than 1, it's a vertical stretch. If the absolute value of a is between 0 and 1, it's a vertical shrink. Now, the main reason they put a distinction between these two is because if a is negative, it's a reflection across the x-axis. The negative part of a is not connected to the stretch or shrink at all. If a is negative, it's a reflection across the x. The number tells us if it's a stretch or shrink. So the sign with a tells us reflection across the x-axis. The number itself tells us vertical stretch or shrink. Questions on that there? G of x equals 2 absolute value of x. Well, we know that this is an absolute value. Do we have a value for h and k? Nope, so it tells us the function is not moving up or down or left and right. But we do have something in place of a, yes? Is the number or the term taking the place of a negative? No. So do we have a reflection? No, even though we do have a 2 there, because that 2 is not negative, there is no reflection. It's only a reflection if the 2 is negative. But the 2 tells us something else. We have a vertical stretch or shrink. It's dependent on what a is. If a is between 0 and 1, it's a shrink. If it's greater than 1, it's a stretch. Is 2 greater than 1? Yes. So what that tells us here is that we have a vertical stretch of 2. Graphically, what that's saying is that our y values, it's increasing faster along the y-axis. It's getting closer to the y-axis. It's getting narrower. A vertical shrink says that it's going to increase along the y-axis slower, so we're actually getting it wider. We're stretching it out. Questions on A? We're good with those here. If you're hearing a beeping noise, you're not going crazy. It's just saying that my headset's about to die. So you may not hear it. If not, that's fine. I hear it every single time. If we feel good with A, you ready to look at B? What is the parent function for 1/2 x squared? Quadratic, yes, because we have that square. It is a quadratic. Do we have a value for h? No, so there is no left or right. How about k? No, so there is no up or down. Do we have something in place of a? Is it negative? No, so that means there is no reflection across the x-axis. But we do have a value for a, so it's going to be a vertical stretch or a vertical shrink. So I can give you a hint, because it's vertical S. Didn't really help. But 1/2, is it greater than 1? No, is it between 0 and 1? So it's a vertical shrink. Now we do have to specify by what amount. It's a vertical shrink of 1/2. We have to give the amount that it's shrunk by or stretched by. That's it. Questions on these here? So So for a vertical shrink of 1/2, we know based off what the parent was, it should be wider than the original one. They're increasing, the y values are increasing half as fast as the parent, as the original function. G of x equals 3x. Parent. Linear. Y equals a times x minus h plus k. What would our transformation be?
Braxton Russell, you need to go back to class. Braxton Russell, you need to go back to class.
Do we have movement up, down, left, right? Do we have a value in place of a? Is it negative? No, so there is no reflection. So that means we either have vertical stretch or vertical shrink. Yes, it would be vertical stretch of 3. Going higher and up. Steeper. Three halves x squared. Which parent? Quadratic. Left and right? Do we have movement left or right? Nope. How about up or down? Nope. We do have something in place of a, yes? Is it negative? No, so there's no reflection across the x-axis. So we're talking about it being vertical stretch or vertical shrink, yes? We have a fraction, don't we? So it has to be shrink. What is our value of a? 3/2. Is that between 0 and 1 or greater than 1? Greater than 1, so it has to be a vertical stretch of 3/2. I always throw that in every year just to make sure, because sometimes when we see fractions, we not necessarily sometimes assume that it's just shrink. We got to make sure, is that fraction greater than 1 or between 0 and 1? Last one, 0.2 times the absolute value of x. Might as well just go on and put it in. It is indeed absolute value. What is our transformation? Vertical shrink, I agree. By or of. Vertical shrink by of 0.2. Questions on any of this here?
What does the x stand for like quadratic?
So x, so all of these here, x is our input, what we're going to plug into the function, our dependent variable. The y is the independent, what comes out. So x just stands for any x value that we can plug into the function. X is input, y is output. Dependent, independent variables. Now, we will have some significance or changes, especially if you remember point slope form, y1, x1. We give it subtext to signify that this actually has a specific value we're putting based off the general equation. But just x and y, input, output. Now, we will get into it later in this chapter, but f of x, g of x, h of x, c of x, it's a way for us to distinguish one function from another. So I can talk about two functions at the same time, and we know what we're talking about. It gives us the ability to say, we're going to look at c of x, and you know immediately which one of these three I'm talking about, not just, especially if they're all just y equals. Kind of hard to specify between them. But